Okay, now let's look at question number 14, part A of the applied paper. So this is the vectors question. So we are given OABC is a parallelogram with OA length A, OC length 2A, AOC angle is 60 or pi over 3. And U and V are the unit vectors in OA direction and OC direction, right? So let's draw this. So we have a parallelogram, right? So OA is length A, OC is length 2A, right? So we have a parallelogram like this: OA BC, and this length is simple A, and this length is 2A, right? So then what else is given to us? AOC angle is given. So this angle is pi over 3 or 60 degrees, right? Then also given U is the unit vector in OA direction, V is the unit vector in OC direction. So that means this vector OA is going to be what? Unit vector is U. In OA direction, unit vector is U. This is magnitude how much? A. So then OA vector is going to be what? A times U. So that we can first find. OA vector is magnitude of OA, which is A, times the unit vector U. Right. Then we know OC. OC's direction unit vector is V, and we know OC length. OC length or magnitude is 2A. So then this vector is what? 2AV. Magnitude is 2A, unit vector is V. So we have found that vector also. OC vector is 2AV. Right. Okay, so after that we want to show OD is equal to this half AU plus 2AV, where D is the midpoint of BC, right? So let's mark that. D is the midpoint of BC, and we want to find OD vector. This vector. We want to find OD vector, right? So let's use OCD triangle to get that. So we know OC plus CD is equal to what? OD, using the triangle law. Triangle law of vector addition. OC vector plus CD vector is equal to OD vector. So we'll write that OD is equal to OC vector plus CD vector. And we know what? CD or CB is parallel to OA. So OA vector and CB vector are the same, parallel and same size. So CD is half of OA or half of CB, which is half of OA. So this is going to be OC plus half of OA, and OC and OA we found. So just substitute here and you should get the answer. 2AV plus half A U. Or let's write it in the form they want. Just rearrange the terms. Half AU plus 2AV. Right. So that is done. First part is done. OD vector we showed is equal to that. Next part is what? Next part is let E be the point on AB. E is on AB such that OD is perpendicular to DE. OD is perpendicular to DE. Right. So let's mark some point. So this is E. So what is the condition? OD is perpendicular to DE. Right. OD vector we already know. DE vector will write down. So DE vector we can write using DB plus BE. DB plus BE. So let's do that. DE is equal to, using the triangle law, DB plus BE. So then what is DB? DB is half CB or half OA. So DB is half OA. And what is BE? BE is part of BA. So we don't know how much this is. So let's say that is K. K times BA. BE is, we can write as K times BA vector or half OA minus K times AB vector. And AB vector is what? AB vector is same as OC vector. So this is just turns into half OA minus K OC vector, right? OA and OC we know. We'll substitute those. OA is this, OC is that. So we have DE, which is what we want to find, as half A U minus K 2AV. Right. So this is DE. And remember we also found OD. OD was half AU plus 2AV. And what is the thing we know about OD and DE? They are perpendicular. If two vectors are perpendicular, their dot product is going to be 0. So OD dot DE is going to be 0. Right. So let's see what that is going to turn out to be. Half AU plus 2AV is OD dot product with DE, which is half AU minus K 2AV is equal to 0. And before multiplying, we'll just cancel this A. A is a length, no? Each term has A, so we can just cancel that. So then we'll have what? Half U into half U, the dot product. So that is 1/4 U dot U, then half U times, or dot product, minus 2 kV. So 2 and 2 cancel, you get minus k u dot v. Then this one is what? 2 times half is 1 and v dot u. Then the last term is 2v dot this 2kv. So that is going to be 4k minus 4k v dot v equals 0. Right. Now let's simplify this using what we know. U dot u is what? That is modulus squared, and that is equal to 1. It is a unit vector. Similarly, v dot v is modulus v squared, and we know v is a unit vector, so modulus is just 1. And we also know another property, u dot v is same as v dot u, right? Okay, so using those three properties we will simplify this. So we'll get 1/4 minus k u dot v plus u dot v minus 4k is equal to 0, right? Let's say this is equation 1. So we want to find the value of k. If we find value of k, we know dE vector, right? So to find value of k, we need to know u dot v value. Without that, we can't find this. So we have to somehow figure out u dot v. So now let's come back here. U dot v, right? U dot v. How do we haven't used this, no? Angle between OA and OC vectors is what? 60 degrees or pi over 3. So we can use what? The dot product formula, OA dot OC. So OA vector dot OC vector is what? Magnitude of OA vector times magnitude of OC vector, angle between those two, cos pi over 3. Magnitude of OA is A, magnitude of OC is 2A, and the angle between them is pi over 3 or 60, right? So we'll use those. And what is OA vector? OA vector is AU dot OC vector is 2AV. OA is A, OC is 2A, cos pi over 3 is half, right? So we can do what? Cancel A, cancel A, cancel 2A, 2A, and we have the answer for u dot v. U dot v is equal to half, right? Sub 2 into 1. Then we have what? Then we have 1/4 minus half k plus half minus 4k is equal to 0, right? Multiply everything by 4. So 1 minus 2k plus 2 minus 16k is equal to 0, or 18k is equal to 3, or k is equal to 1 over 6, right? So now we can find dE, right? So dE is what? Half AU minus k 2AV. K is what? K is 1/6. We found that, no? So minus 1/6 2a v. So simplify, half a u minus 2 and 6 cancel, so 1/3 a v. Right. So that is what we wanted to show now. So right, DE is done. Then what is the last part? Let F be the point of intersection of extended OA line and DE line. Right. So let me erase this part. So we have to extend OA line and extend DE line, and the point where they meet is O is F. So we want to find OF vector, right? We want to find OF, right? So right, we can write what OF is what on OA line. So OF vector is what, lambda times OA. So OF is lambda times OA. O, that is what, lambda AU, right? That is one way of finding OF, right? We need to find OF in another way. We can do that. What, we already have OD, no? OD plus DF. So that is another way of finding OF. And DF is what? DF is mu times DE. It is parallel to DE, no? Or it's on DE line. So we can write this as OD plus mu DE, and OD and DE we already found. OD is this, D is that. So let's substitute. So OF is equal to half AU plus 2AV plus mu. DE is what? DE is half AU minus 1/3 AV, right? Okay, so let's simplify. OF can be, so let's make this as equation 3, and let's simplify this equation. So you get half AU mu over 2 AU plus 2 AV minus mu over 3 AV. Let's take this as 4. Then 3 and 4 are equal, no? Both are representations of OF vector. So we'll equal 3 and 4. So then lambda AU is equal to half AU, right? So each term has A, no? I'm just going to write these without A. See, this term has A, and every term on this side on equation 4 also has A. So I can simply cancel that, no? So this just turns into what? Lambda U equal half U plus mu over 2U plus 2V minus mu over 3V, right? So let me move everything to the left hand side and group them. So I can do what? Lambda minus half minus mu over 2 u plus mu over 3 minus 2 v equals 0, right? Let's say this is equation 5, right? So consider equation 5. So that is what, lambda minus half minus mu over 2 u plus mu over 3 minus 2v, mu over 3 minus 2v equals 0. And what do we know? u, v are non-zero and u, v are non-parallel. Then using a theorem, we know what? This part has to be equal to 0 and this part has to be equal to 0 at the same time if this statement is true. So we can write lambda minus half minus mu over 2 has to be equal to 0 and mu over 3 minus 2 is equal to 0. So that means mu equals 6. Then substitute that here. We get lambda minus half minus 3 equals 0, or lambda equals 7 over 2. And we know what OF is lambda AU. So that means 7 over 2 AU. So that is the last part we needed to show in question number 14 part A. So we have done that, right? Okay, next we will look at question number 14 part B.